A marble of mass m is launched vertically upwards with an initial speed v0 equal 20 meters per second. The effect of a resistance is neglected and the gravitational acceleration strength is g equal 10 meters per second squared. Determine the time equations that govern the motion. In order to determine the time equation that governs the motion, we need first to specify the type of motion and to know whether the motion is uniform, or in other words, if the speed is constant and the acceleration is zero or not, or if the speed varies and the acceleration is positive or negative. We need to apply Newton's second law to find the acceleration in this case. So according to Newton's second law, the sum of external forces is equal to ma vector. The only force acting on this marble is the weight, because it's free in the air, and a resistance is neglected. So W vector is equal to ma vector. Doing projection along y-axis as long as the motion is along y-axis. So we have to say minus W because W is downward, so minus W equal ma. Then A is minus W over m. W is mg, so we have here minus mg over m and m cancels, A equal minus g, which is equal to minus 10 meters per second squared. So obtaining a constant acceleration, -1, then the motion is udrm, uniformly decelerated and rectilinear because it's moving along a straight pathway vertically. Now the time equations for udrm is y equal half at squared plus v naught t plus y naught. Why did I say y not x? Because simply the motion is along y-axis. Doing the substitutions, y equal 0.5 is half, or half is 0.5. A is minus 10 t squared plus v initial is given to be 20 meters per second, plus the initial position is 0 because it started from the origin of the y-axis. It started moving from the origin of the y-axis. So y equal minus 5t squared plus 22 in the SI unit. Now the speed time equation is v equal 80 plus v naught. A is minus 10 and v naught is 20, so v equal minus 10t plus 20 in the SI unit. To calculate the maximum height OA reached by the marble. When the marble reaches a maximum height, it stops. So VA equals 0 meters per second. Now I want the maximum height, I want the distance, and I'm not given the time at which it reaches its maximum height. So in order to avoid doing two steps, calculating the time, then finding the distance, which represents here the height, we can simply use this formula also from the previously discussed lesson. VA squared minus V naught squared equal to AD. VA is 0 because it stops at the maximum position, minus 20 squared started at 20 meters per second. 2 into A is calculated minus 10, and the distance covered is OA, which we are looking for. So we get here minus 400 equals minus 20 OA. OA is minus 400 over minus 20, then it's 20 meters. Now 4, determine the time the marble Now, what is the height attained by the marble when the speed is half the initial one? This should be divided into two steps. In the first step, we calculate the time needed to reach half the speed, and in the second step, we calculate the distance. So V equal half of 20 meters per second is 10 meters per second. Substituting in the speed time equation, V equal 80 plus V naught, 10 equal minus 10t plus 20, t equal 10 minus 20 over minus 10. This is minus 10 over minus 10, which is 1 second. In the second step, t equal minus 5t squared plus 22. Substitute 1, we get minus 5 plus 20, so this is 15 meters. Here d is the distance covered, or it's actually y minus y0, and y0 is 0, so d equal y in this case. Now, 4, determine the time the marble needs to reach the ground again. So reach the ground means y equals 0 meter, y equal minus 5t squared plus 20t. 0 is minus 5t. We're factorizing here, taking minus 5 in common, so and t in common, so minus 5t. We are left here with t minus 4. So when we have the product of two factors equals 0, either the first is 0 or the second, then here we say that then minus 5t is 0. This means that t equals 0 seconds, which is the initial instant. We are not looking for the initial instant. We know that already the object started moving at t equals 0 from the ground. So we're not looking for this part. We want the other one, or t minus 4 equals 0. So t equals 4 seconds. We are looking for this one. Okay, so at t equal 4 seconds, so it takes it, after it starts from 0, it goes up, then after 4 seconds, it reaches back the ground. Now finally calculate the velocity of the marble when it hits the ground. At t equal 4 seconds, v equal minus 10t plus 20 minus 10 4 plus 20 minus 40 plus 20 minus 20 meter per second. Why did we obtain a negative value? Because it's moving in the negative direction of the y-axis. So as a vector, we need here to express it as a vector because we're asked to find the velocity. So v vector is minus 20j vector. Why did I use j? Because you know that j vector is the unit vector of the y-axis. So it's minus 20j meters per second.